All right, our goal today is to solve and graph inequalities in one variable. So we do have some rules for inequalities. So part one is just simple inequalities. Then we will get on to part two, which won't be until next week. But that's what we call compound inequalities. So today we're just going to work with our simple inequalities. And so there are some rules that we have to know. It says the rules for solving inequalities are going to be the same as the rules for solving equations. So whatever you're going to do to one side, you have to make sure to do to the other. So as Ms. Steffi brought up, if that line helps you to kind of keep things balanced, you are more than welcome to do that. So in order to solve equations, we use those properties of equality. The only difference in when we solve inequalities is that if you multiply or divide both sides of an inequality by a negative number, there's a rule. And you guys should have learned this in Algebra 1. Does anyone remember that rule if you multiply or divide by a negative number? There's something that you have to do with the sign. What is it? Yes, you have to flip it. You must flip the sign. Okay. So graphing inequality. So once we see this inequality, we do some solving, we get the variable by itself. Inequalities are graphed on a number line. So when we are working in one variable, we graph our solution on a number line. They're easier to graph when the variable is written on the left and the number is written on the right. So for example, it might look like this. Okay, that'd be an example. X is less than 4 is how that would be read. That would be your example. Okay. If you're using less than or greater than, okay, when we go to graph these, you're going to use an open circle. That was okay, so it's going to look like this when we graph. Okay, and then you'll shade left or right. If you use a less than or equal to, or the greater than or equal to inequalities, then you use a closed circle. So you would color it in. That means that whatever point you draw that circle on is included as part of your solution, okay? And then from that circle, you're always going to shade left for less or right for more or greater. Right. As long as your variable is on the left side. So that's kind of your key. You have to put the variable on the left. Then if your sign is less than, you shade less, left. And if it is greater than, you're going to shade right. Okay. For example, x is less than -3. When we go to graph this, you want to make sure you have a 0 on your number line. So I'll put 0 there, -1, -2, -3. I just did my scale by halves. You can go up by ones though, it doesn't matter. Okay. So there's my scale. Now that's less than, so I'm going to have an open circle, and it's going to be right on -3. So an open circle at -3. And then it says x is less than, so less than says to shade left, so I'm going to shade left. And it's kind of nice because the arrow literally points in the direction of the direction I have to shade. That only works if you actually have the variable on the left. Okay? And then you can test it. So see how you have -4 is shaded? Is -4 less than -3? Yeah. So I shaded the correct way. You can always test one of your numbers that are shaded and make sure that you actually shaded the correct direction. Okay. If x is greater than or equal to -1, again, let's put a scale on here. Now this one is or equal to, so I'm going to have a closed circle at -1. So I'm going to make it solid. And then this one is greater, so I'm going to shade right, and you can see that it's pointing towards the right, so that's the direction that I'm going to shade on my number line. Now, what's a number that's part of my shaded solution? 0. Okay, is 0 bigger than -1? Yep, so it works. So I shaded the correct direction. Okay. So then we have some examples where we're actually going to have to do some solving. Okay, x is not just given x is bigger than or less than a certain number. Instead, it has 3 is greater than x minus 6. So you have to work to get x by itself. You're going to solve it just like an equation, but don't forget that new rule. If you multiply by a negative number or divide by a negative number, you must flip the sign. Okay? So in this one, x minus 6, we want to get x by itself, so we're going to add 6 to both sides. Again, we want that x to be on the left side, so x has the pointed part of the sign. So when I flip this, I need that pointed part going towards x. The open part is on the side with 9. So when you flip that whole statement, you have to flip everything. Does that make sense? It's almost like you literally took it and made it backwards. Are we okay with that? Okay, so then we have to go about graphing this one. So this is your solution. And this down here is the graph to our solution. Okay. Are we going to use an open circle or a closed circle? Open. We put that at 9. Am I going to shade to the left or to the right? To the left. See how it's pointing to the left? And now let's test a number. 0's shaded, and that's an easy number to plug in. Is 0 less than 9? Yeah, cool. I shaded the right way. And even if you put it up here, is 9 bigger than 0? Yep. So I did it right. You could plug it back into your original. Is 3 bigger than 0 minus 6? 0 minus 6 is -6. Is 3 bigger than -6? Sure is. So I'm on the right path. Okay. Let's try for number 2. Well, this one we have x on both sides, so things might get a little bit tricky. But that's okay. We just have to move x all to one side. So do you guys want to move the 3x or the 6x? The 3x. Now remember, if we move the 3x, what side is x going to be on? The right side. So in the end, we'll have to flip it. But that's okay. If you guys want to do that, we can do that. Some people like to move it to the left since that's where they know they want it to end up anyways. Okay? But some people don't like to do that because then they're going to know they're going to be dealing with a negative number. Let me check one thing before we actually do that. No, let's actually move it to the left because I want to show you guys having that negative number. So if we subtract 6x on both sides, the 6x's go away. We have -3x minus 10 is less than or equal to 14. Again, you could have done it either way. It doesn't matter which side you decide to move the x's to. All right. Now we still have to get rid of that minus 10 part. So we're going to add both 10 to both sides. We have -3x is less than or equal to 24. What comes next? Divide by -3. Oh no. You just divided by a negative number. When you divide by a negative number, you have to flip the inequality sign. So from less than or equal to, this is going to change to a greater than or equal to because you divided by that negative number. 24 divided by negative 3 is negative 8. And we'll make a little note here. Divided by negative 3, flipped the inequality sign. Did we see how that worked? Now, as some people wanted to move that 3x, that would have been totally fine. But in the end, we would have ended up with negative 8 on the left is less than or equal to x on the right. And when you flipped it, you would end up with this exact same answer. So it doesn't matter which side you decide to move things to. If you do all your right steps, you're still going to get to the exact same solution. Okay? All right, so we're going to need negative 8 on our number line. So I'm going to put 0 here. Negative 2, negative 4, 6, negative 8, 10. Okay. Open circle or closed circle this time? Closed. So a solid circle on negative 8. Am I going to shade to the left or to the right? To the right. The arrow pointing to the right. So I'm going to shade in that direction. I could pick a number like 0. 3 times 0 is 0 minus 10 is negative 10, less than or equal to. 6 times 0 is 0, plus 14 is 14. Is negative 10 less than or equal to 14? Is that correct? Is this true? Yeah, then I shaded correct because I have the answers that are the solutions are shaded. Okay. And all I did there was plugged in 0 here. When you multiply by 0, it goes away, right? So that's how that side ended up being negative 10. 6 times 0 is 0, plus 14 is 14. So 0 is super easy to plug in. That's why I typically will plug in 0 if I can. And then if 0 is not a solution, if you plug it in, it shouldn't work. All right, let's flip it over. Okay. Now, I keep saying that we're not allowed to use decimals, that we're going to leave everything in reduced fraction form. If we're given a problem like this, where it gives us decimals, this is when it would be acceptable to have our answer written as a decimal. Okay? So in this case, what I'm going to do is divide both sides by 4.2. Do I need to flip the sign here? No. Even though that is a negative, that's not what I care about. I divided by positive 4.2. So nothing happened with the sign there. I still have a greater than or equal to sign. I have x on the left. Anyone have a calculator? What's negative 31.5 divided by 4.2? You get negative 7.5. Does that look right? Negative 7.5? Okay. All right, so now we have to graph that. So I need a negative, so I'm going to put my 0 over here. Negative 2, negative 4, negative 6, 8, negative 10. Negative 7.5, am I going to put a solid or an open circle? Solid. And this one, you have to make sure you do put that circle in between negative 7 and negative 8. So in between those two, we have that solid circle. You can even label it negative 7.5 right on top. That way you know what that number is. Am I going to shade, if it says x is greater than or equal to negative 7.5, am I going to shade towards this negative 10, or am I going to shade towards 0? Towards the 0. And there we go. This is how you write your solution. And that's how you write your graph. Okay. Now this last one has this fraction in it. And nobody likes fractions, so what can we do if our fraction is dividing everything by 6? That's what that fraction says, is divide by 6. So how can you undo fractions? Multiply by that denominator. If that's dividing by 6, multiply both sides by 6. And what happens is multiplying by 6 and dividing by 6 goes away on the right. And on the left, we're going to get 6 times 2c is 12c is less than 12c plus 58. Are you with me so far? Okay, well, what can we do next? Subtract 12. Well, shoot. This is weird. 12c minus 12c on the left side, what are we left with? What are we left with on the right side then? Not 0. 58. Okay? This is not your solution. Okay? Some people tend to write that as a solution. So when we have the solution line, they try to write that on the solution line. That is not your solution, though. This is going to be what tells you what your solution is. Because no matter what you plug in for C, you'll get a statement that looks like this. Okay? Is this a true statement? Is 0 less than 58? Yes. That means we could plug in this number down here and it will work. We could plug in a number over here and it will work. We can plug in a number here and it will work. Because no matter what we plug in for C, we're going to get this true statement. So that means whatever we plug in is going to work, so everything is going to work. So our whole number line is going to be shaded. Well, what numbers are our solution if the whole thing is shaded? What numbers are on the number line? What is it? Well, those are numbers that are on there, but there's a lot more numbers on a number line. Do we have natural numbers on a number line? Oh, well, we have 0. That means we have whole numbers on a number line. Do we have negative numbers on a number line? Yeah, we put negative numbers on this one over here, right? So that means we have integers on our number line. Are there numbers in between those integers on our number line, like fractions? Yup. Okay. Can we figure out where irrational numbers would be on our number line? Like the square root of 3? Can we kind of estimate where those would be on our number line? Okay, so if all of these groups are on our number line, what is the number line made up of? Everything. So what is that biggest number set that we know? Does anyone remember what that big number set was called? The real number set. Okay, so that means our solution is all real numbers. All real numbers is going to be our solution because everything is a solution on our number line, and your number line is the real number line. It's the real number set. And it's important that you know that Venn diagram because, like I said, that's going to be on your quiz again this week. Of where does it fall, and you have to know. Okay? And the whole Venn diagram are all real numbers. And then you have the individual smaller sets within it. Okay? So we just saw what happens when the variable term cancels out. But sometimes we get a true statement. Okay, so if there is a no variable and the inequality is true, that's what we just saw that happens. What is your answer going to be? What did we have for our actual solution or our actual answer? All real numbers. And our graph was shade everything because the number line is all real numbers. Okay? So what do you think happens if this was false? If this one's everything, what would it be if it was false? Nothing. It's no solution. So that one would be no solution. And for your graph on that, just put 0 on it and put maybe a scale on it or something then I at least know that you know, looked at it and said, okay, there's my number line. I don't shade anything.